Okay. Just to start off, we've got Leo at the back. He's a student teacher, is that right? And he's just going to observe for the first 20 minutes. So please make him feel welcome. Um, okay. Yeah, I used to be a student teacher, obviously. It's a pretty, that's where you learn most of your,
Yeah, so my major subject is mathematics.
okay. Yeah.
Mine is chemistry.
Chemistry, okay. Chemistry's, for me, chemistry was harder than maths. The exams in chemistry, who's doing chemistry here? Okay. There's a lot of maths in there, but I found it much harder. But that was a long time ago. I'm sure it's still pretty hard. Yeah. Today I'm going to do 6, 5, and 6, 6. Also, good news, your sack is not on Monday. Okay. We pushed it back to Friday. Okay. So
Next Friday, right?
not this Friday, next Friday. Friday, May. What's today's? The 9th? It's the 9th, okay? So you get to breathe a little bit. But the downside of that is we still, on the periods leading up to it, we still got to get into chapter 7, probability. So you're kind of double handling two topics while two sacks are coming at you very quickly, one after the other. Okay. So that's the downside. Any questions, eh?
Are we doing a sack or what are those investigations for chapter 7?
So for chapter 7 is an investigation.
Okay.
Yeah. So we'll do a little bit of teaching. You do the sack, come back to a little bit of teaching, back to the sack.
Okay.
It's about 3, I think it's about 4 periods, that investigation.
What kind of investigation is it?
Probability.
Okay.
Yep. Probability. Any other questions? Yes. Over 4 periods. Sack number 3. Then very quickly after that is your exams. It's happening really quick. Any other questions? No? All right. So today got a double period. I'm hoping. I keep saying when it's hopefully it's short, but it ends up being quite long. So I'm not going to promise anything here today. Today we're going to start off. We're going to finish chapter 6, inverse functions. Who knows? Well, did you do inverse functions last year? Is this a new topic for you? Inverses? Hands up if the word inverse means nothing to you. Nothing. Okay, hands down. Hopefully it's going to mean something to you after in the next 30 minutes. Inverse simply means it's like a reverse, or everything is mirrored. It's a mirror. But our mirror, remember how I talked about reflections on the x-axis that do this? And reflections on the y-axis do this. But now we've got a reflection on the equation y equals x. And we all know, I'm hoping, that we know that y equals x is here. So we have a reflection over a diagonal now. Okay? So, for example, you can reflect dots, you can reflect whole lines. And it's a very big topic in methods. So you need to know what you're doing. For example, 2, 3, 1, 0, negative 2, 4. 2, 3, 1, 0, negative 2, 4. Negative 2, 4. You've got the notes for this after. I'm going to label these first. I was going to call people up to answer this question, but it takes a while for me to edit you out of the thing. So I'm being a bit lazy. Okay. Describe the inverse function as a set of ordered pairs. Give the domain and the range of both. Okay, so we have a normal f of x. What do I mean by the domain? Can someone tell me? I'm going to cold call someone right now. Jesse, you weren't looking at me, so I'm going to choose you. Domain, what does domain mean?
Range of axes, isn't it?
Good. The range of the x's, okay? Looking at our range of x's, okay, what x's can you see, Hudson? There's a 1. What else can you see, Hudson?
2 and then 2.
2? There's a 2. What else is there?
-2.
And then -2. Okay? So we have 3 numbers there that fit the domain of f of x. Let's do it for the range. Maya, what do we have here?
1, 3, and 4.
1, 3, and almost. It's 0, 3, and 4. Why do I have curly brackets, Amy? Why? Curly brackets. What's the difference between a curved and a curly? That's okay. If you don't know, there's nothing wrong with that. Tim,
Listing numbers.
it's just listing actual numbers. You're jumping from dot to dot. We're not including in between values. You know when you do a hopscotch, you're jumping from one number to the other, not in between. That's curly. Okay. So let's now plot our reflecting. This is our mirror. Okay, so you guys look in the mirror every day. I hope you do. It's okay to look in the mirror. Myself and Mr. Schiff have a running joke in our office next to T1 because all the VCE kids, they walk past our window and it looks like they're looking at us and smiling, but they're actually looking at their reflection in the mirror. Okay, we were going to put a sign there that says, you look nice today or something like that. Okay. That's y equals x. All we're going to do is reflect y equals x. What does that mean? Whatever x is, we're going to change it to y. So if I had 2, 3 here, we're going to change them up. Instead of 2, 3, I'm going to have 3, 2. So 3, 2. 3, 2. Okay, so if you lean your neck to the right, you can see it's symmetrical on that line here. Okay, if I have 1, 0, Emily, what does 1, 0 turn into?
0, 1.
0, 1. I should have done these in a different color. Once again, if you lean to the right, it's a reflection. Lastly, -2, 4. All right, Nathan? Or -2. Or -2. Okay, it's just reflecting dots. But let's look at the domain and the range of our inverse. Now, inverse, the sign for it is at -1. It's not to the power of -1, it just simply means inverse. Let's do this again. Now, I'm going to color code our inverses in green. So, which was this one here. It was this one here. And it was this one here. Okay, let's ask some questions. Okay. Zach, domain of the inverse of the green.
0 to 4. Or 0, 3, 4.
0, 3, 4. Okay. Amrita, the range of the inverses, the y values. -2, 1, and 2. That's all right. Yeah, red, green, colorblind. Just joking. Just joking. What do people notice? Today's lolly. They switch, Hudson. What switched? The domain and range. Okay, so you see domain of fx is now the range of the inverse. The range of fx is now the domain. So you don't have to work it out. You can just see that it's just a straight swap. Okay. All right. So domain of f is the ran, or the range of the inverse, and the ran of f is the domain of the inverse. Any questions with that? Okay. Next step, we're going to inverse, not just dots, but a whole line. All right, just give me a moment to wipe off the board. Any questions? For now. I'm going to leave that for y equals x in there. Okay, so I'm going to scroll down to the question so I don't have to write it out. To save a bit of time. Okay. Sketch the function g. So if it's f, it's f. If it's g, it's g. Just be okay with the letter. 2, 4, that spot here in our notation. What does that spot represent? What does that spot represent? Okay, we've got the equation section here, but every equation is linked with, Gabe?
Domain and range.
Well done. Just the domain. Okay. They only quote the domain because the domain affects the range. They just need the domain first. So you can see here that our domain of our G is from 2 to 4 straight away. Okay. If you know that, if we're doing an inverse, what do I know straight away of the inverse? With 2 to 4. It's the same concept as Hudson pointed out, that they swap. We still need to know what the range of G is and also the domain of G inverse. They're still unknown. We'll find them out later. State the domain and range for Gx and G inverse x. We've done the domain first. Okay. We've got our equation here, y equals 2x plus 1. I'm going to graph that. What's the easiest point to graph of y equals 2x plus 1? What would you do? Y-intercept, as Tim is suggesting, at 1. Oh, that's part of it. Yeah. At 1, it's a 2 to 1 ratio. So I go up to 2, 1, 2, and across 1. It's back there. Just going to measure that. Okay. So I'm going to graph that in. Now, if I do that, hopefully this is not going to get messy. I didn't do my scale too nicely, to be honest. I'm going to restart because I need to get to 4. If I get to 4, I'm drawing on the wall. which I don't want to do. Let's just reset. I'm going to do this instead. Okay. So raise 1 up to 1, 2 to cross 1 is about. I might actually still need to go against the wall, unfortunately. Hopefully. I am actually. I've got the drawing up anyway. Okay. I'm going to slightly adjust it, but it's going to look a bit wonky. Okay, have I graphed this line right? Have I sketched this properly? Emily says no. Why would you agree with Emily? She is right. The domain, okay? It says focusing on domain. What is it about the domain that we need to apply here? Nathan, would you know?
Just the values in the domain.
Just the values in the domain. Good. 2 to 4. Do I need the intercept? Is it within the range of the domain? No. So I'm going to cut that back. I actually don't need it. I don't need it. So I'm at 2. And I've got up to 4. 2 to 4. I hope that's going to come off. 2 to 4. I need to know where it reads off. But how do I know where it reads off? What can I do mathematically to find out what coordinate that is? I've got. What would I do? Sorry, Tim. Substitute. Thank you. Okay. So I want to get to 4. We're left with 9. So up here is a 4 9s. It looks really bad. 4 9. Okay. Now, if I want to reflect 2 to 3, if I want to inverse 2 3? Sorry.
What you've got is 1. Makes you 1.
Ah, yeah, it's actually 1 3. Correct. Correct. Thank you. I've made a big mistake. And it's all on YouTube. I might have to do some editing out. It's 2 to 5. Thank you for that. Right back. 2 to 5. Okay, we're correct now. Thank you, Tim. 2 to 5. 2 to 5 changes into, if I want to inverse it. Why am I inversing? Because I want to find the inverse of x. I want to sketch it. So it's 5 2. 5 2. Which is so. Now, it doesn't look like it's mirrored, but it is. Can anyone explain why?
If you're going by 2 domains.
Yeah. If you want to properly look at a proper mirror, don't play around with your axes. These are going by 2s, as Tim said. These are going by 1s. So it's still mirrored, but it doesn't look like it. Okay? On the notes that I have, it will be mirrored. 4 to 9, Amy, 4 to 9 turns to? 9. 9 4. Up here. Okay. Now remember, this is a range. It's an equation. So it's not 2 dots. It's actually 2 lines from there to there. Let's complete it. For the original graph, which is up here, what's my range Z? If I'm going from 2 to 4, what are the Y values doing? They're going from
4 to 2.
Not quite.
Oh,
The y values from here to here is 2 to 4, but for the y's it is
5 to 9.
5 to 9. Okay. Likewise, Maya, what do I put in here straight away? 5 to 9. And I can see that. For our inverse, it's 5 to 9. For our inverse, it's 5 to 9. Okay. Now, we haven't actually sometimes they'll ask for the equation of this. Okay. Now, for every inverse function, the first step, we want to reflect the y's and the x's. So in order to find our inverse, my y's become x's and my x's become y's. That reflects everything. So therefore, to get back to y equals, what's the first step I need to undo, Perry? I want to get y by itself. Go to -1. What's my next step, Hudson?
No idea.
Let's say, what's y times 2? Opposite of timesing by 2. Divided by 2 on the other side. Now, we can then separate an x on 2 by itself minus a half.
Or just leave it as related. It's not one.
You can, but it's up to you can do either. Okay. But usually the questions do like it as a normal y equals format. If you graph that, it's going to look like this. Okay. That's the equation for this line. Okay. And remember, each equation has with itself a domain. But which one am I using here? 5 to 9. These two are attached. Okay? Range just looks after itself. But if they ask you to calculate it, you need to go ahead. Okay? Any questions?
What's the R mean in the question?
The R, that's just real numbers. So we're mapping 2 to 4 onto any possible number that we can. Okay. Any other questions? Okay. Next one. You can see there, it looks like it's quite mirrored precisely. Okay. Next question. Find the inverse of the function 1 to infinity domain to R again. Function of x equals x minus 1 squared plus 2. Okay. So that's f of x. I now want to find the inverse. What's the first step that I said just before in order to find an inverse?
Check Y.
So
Switch X.
switch x and y. Okay. What's the first thing I need to reverse here, Jesse?
-2.
Thank you. Okay. Zach next.
Square root.
Square root it. Okay. Gabe, what do I do next?
+1.
Plus 1. Okay, this is incomplete. Why? And it's not because the domain's not attached. There's something that we need to consider.
Also minus the root.
Thank you, Jesse. Okay, that's worth a look at. Okay. Square roots are pluses and minuses. Okay. Now I'm hoping that when I sketch this one, I don't have to deal with the axes. Let's see. Let's keep the axes even. Yeah, this is okay. Okay. What sort of graph is this, Nathan? Our normal graph. It's a quadratic. Okay. What can you see straight away as a feature of this quadratic, Amrita? What? This equation here, the way it's written, what is it telling you of its graph? At? Good. Okay. Notice the domain starts at 1 as well. So this quadratic is only starting here. Okay, let's do another secondary point to guide us, like in the constellation of the stars. If I put a 2 here, 2 take away 1 is 1. 1 squared is 1 again. 1 plus 2 is 3. So 2 goes to 3. Okay, if I do it again, 3 take away 1 is 2. Square root is 4 plus 2 is 6. 3 goes to 6, roughly. So we have a nice trajectory, especially when you're sketching. In your exams next year, when you're sketching, they have proper grids where you can't muck up the grid. You're not going to draw your own grid. They'll be there for you to do properly. Okay, we are not interested on the left side of the quadratic here. Okay, because our domain. Okay, let's play around with the domains and the ranges. Ever think about what they might be? Straight away we know it's 1 to infinity. What is the range of our normal graph here? Where's it going from, Emily?
The range is going from 2 to 8.
Yep, 2 to 8. It goes past 8, and where does it end up? Infinity. Okay. Having these already, what's the automatic step that we need to do now, Zay? If we've got these, what can we do with these?
That means you can, the range, the domain, the bottom domain is 2 and infinity.
Good.
And the bottom range is 1 and infinity.
Excellent. Okay. That sets us up for actually graphing what we need to do. We're going to now draw this. We did this just a few days ago. What is this, Maya? What sort of graph what do we call this? That's okay. Who remembers?
Square root graph.
It's a square root function. Good. And square root functions, something specific about square root functions. What do they all have? They don't. Good try. Try again. endpoint. Zaggy, were you going to say that?
Yeah.
You got to back yourself. Okay. Endpoint. What's the endpoint of this, Tim? Endpoint.
2.
2 and
Negative.
no.
1.
1. Correct. So we know it's really bad language, but the square root starts at the endpoint. The endpoint being 2, 1. Okay. This is where it can get a bit tricky. All right. Here, we've actually got, this is a very common question, by the way, in sex. We've actually got 2 equations happening here. Okay, one's a positive and one's a negative. Okay, so if I've got let's do the positive one. Okay. Positive square root function. Remember, we talked about positive square root functions do that. But when we whack a negative on it, which way does it reflect? Down. That negative in front, not in there, but in front, whacks it down. So we have a positive square root function, but we have one that goes like that. Okay? But if you look carefully, these are actually 2 separate equations. Okay? Looking at your reflection, so this is blue. This is red. If you want to reflect the black on the y equals x line, which one do you want, Zach? Do you want the blue or the red?
Blue.
It's blue. We're after blue. Okay? We're not after red. Blue, red, blue pill, red pill. You know. Okay. Okay. You've all seen The Matrix. Yeah. Okay. Why must I get rid of the red equation? Escape.
Because it's not in the domain or range.
Excellent. Excellent. Okay. Let's see. That's a good pickup. Let's explain what Gabe just said, and then we'll take a mini break. No worries.
Thank you so much.
No worries, Leo. Have a good day. Okay. Let's look at the domain. Let's look carefully. The domain of this one here. Looking at the red that I just erased out. What's the domain of this red? Amy, what are the x values of this red? Where does it start? Starts at 2 and goes to infinity. Okay. Now, let's do the range. Its range. Where does it start? Good. Negative infinity. Good, Maya. And where does it stop?
1.
At 1. Stops at 1. Okay. Now, but does this domain fit nicely into here? They're the same. Okay. There's nothing wrong with that. But let's look at the range. We want a range that only goes from 1 to infinity. Okay. Does blue fit that? Does blue line fit 1 to infinity? The blue one, not the red, the blue. The range. It does. Goes from 1, goes to infinity. Let's look at the red. Red range. Does this range fit into here? It doesn't. The range does not line up. It can't work. We stick with the blue. We erase the red. And mathematically, that sits well with that visual of a reflection on y equals x axis. Okay. When you have a conclusion, if it's an inverse in maths or whatever, you need a visual that's supported by maths. Okay. This is the maths. Yes, sir.
In a SAC, do you like actually have to give a reason or
Yeah, you do.
you actually do?
You have to show you gotta show it. Okay. We're gonna take a break. Because we've got we've got a new concept to teach. 1, 2, 3, and I think I've been talking for too long. Okay, you can stretch your